Hey guys, we're thinking about a solid, right? So we're going from a sort of two-dimensional figure, right? Something like on a coordinate plane, you might draw a parallelogram, right? Where it has a base and it has a height. It's two dimensions. And when we have something that is solid, like maybe we have this big die, right? In order for this to be three-dimensional, you could say that a solid is something that is a three-dimensional figure that encloses a space, right? So this is essentially there is space sort of inside of here that's being taken up, and it's created in a specific way. So there's parts that come together to make a three-dimensional figure. So you have a face, right? So this right here is a face, or it's the flat surface, right? This is a cube, so it has 6 different faces. You also, in a three-dimensional figure, you have an edge, right? So an edge is the sort of side, right? It's a line segment that connects two faces. So if we have this 6 here and this 5 here, this right here is the edge, right? It connects these two faces together. And we have a vertex, which is sort of a fancy word for a corner, right? Where you have sort of 3 or more, sometimes more, depending on the shape, edges coming together, right? So right here we have edge, 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 and they meet at a corner, or what we call a vertex. So if we take that idea and here we have a rectangular prism, it's gone from a cube like we have here, a cube meaning that all of the side lengths are the same length, right, to make it a cube or a square shape turned three-dimensional. Here we have a rectangular prism. So what this is pointing to here is the edge, right, that line. You could think about the flat part. What might that be called? Do you remember? Yep, it's the face. And then the corner. What's the fancy word for a corner in a three-dimensional shape? It's the vertex. So what your job is here is you're going to be finding the number of faces, the number of edges, and the number of vertices or corners that each of these solid three-dimensional shapes has. So when we think here on this first example, let's get the pen going. If we think about faces, right, we think about those flat parts. You might use some colors to help you if that sort of makes sense to you. So I'm thinking about these side pieces that kind of go up and down. They're these long rectangles. I know these are going to be the same size. There's 2 of those. There's a bottom and there's a top, right? And then the final faces here are we have a front face, and then on the back here, we also have the back face. So in total, we have 6 faces in this rectangular prism. If we think about edges, right? Edges are the parts that come together, these sort of edges here, where 2 faces might meet. So we have 1, 2, 3, 4 edges here. We have 1, 2, 3, 4 edges on the bottom. And then we also have 1, 2, 3, 4 edges kind of coming together, holding this shape up and down. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Interesting, we have double the amount of edges as faces. And the vertices, right? So the vertices is a sort of fancy word for corner, right? So where do those edges meet? Well, we have 1 meeting, 2, 3, 4. And then down here we have 5, whoops, 6, 7, 8, right? So we have 8 spots where those edges come together and meet at a corner. So go ahead and try this one out over here. We have sort of a triangular shape to this solid. So you could still think about, even without knowing what type of shape specifically this might be yet, you could still think about how many flat faces does it have, how many edges, and how many corners or vertices.